Alright kids, today in this video we're going to be going over the information in topic 14.2 on pages 366 and 367 in your Pearson book, and we're going to be looking at data sets. Alright, so why don't you open up your book, get out your notes, and we'll begin the video lesson. On page 366, they give us our introductory information and question. And it asks us, how can you describe a data distribution? It then explains a little bit about the way data is distributed in reference to this dot plot over here. We can describe a data distribution, or how data values are arranged, by looking at its overall shape, its center, and the least and greatest values. So in other words, if you were to look at this dot plot over here, you'd see that this is the data. It's talking about calories in fast food hamburgers. Alright? And you can see several things just by looking at this data and how it is distributed. For example, the book goes on to explain the different ways you can look at this data. For example, they talk about the spread of the data. So when we look at the data and we ask ourselves, well, what is the spread? We're talking about how it looks from start to finish. Okay? And in this case, this data is spread to the right. In other words, when you look at it, you can see that it's kind of pushed this way. You've got these few little dots out here that kind of draw it to the right. In other words, it is spread to the right. The other thing we notice about this data is we look at the least value of 200. And then we look at the greatest value of 1500. So looking at the data's least and greatest values of 200 and 1500 tells us something about the spread of the data. The center is exactly what they're talking about. Where would the approximate center be? And in this case, the center is somewhere around right here, which would be between 6 and 800, which would give us 700 as the approximate center. Another way of describing this data is to look at its overall shape. And in this case, the overall shape is not symmetric. In other words, it's not symmetric because its center is somewhere around 700, and you can tell that it kind of goes like this, and then it kind of spreads out that way. If it were symmetric, you'd have the same looking curve on this side as you do over on the other side. Okay, so the data is not symmetric. Another thing that we can do is we can say the data is grouped between 400 and 1200. So in other words, if we were to say, well, where is the grouping of the data, or where is the data falling most, you could say between 400 and 1200. And that's important because then suddenly we can deal with these amounts as perhaps something not quite a part of the regular grouping. Alright, so it depends on what you're asking, but it's important to know where the data is grouped and if there is any grouping in the data. Alright? And then the last thing you'd look at is you could make the statement that some gaps exist in the data. In other words, if we were to look at gaps, we could see that this is kind of a gap right here. There's kind of a gap right here, and there's kind of a gap right here. You know, there's no gaps right here because they all seem to be lining up consistently. But then all of a sudden you jump to some data, you have a couple sets, then you jump the data, and then you jump the data there as well. So therefore, we could say that we do see some gaps in the data. All right? So that's kind of an interesting way of looking at data. But then we do something different. A dot for a large 2,000 calorie burger is added to the data. That puts the data way out here. And so we can see that we still have data that is not symmetrical, and it's really being kind of spread to the right now as a result of that one burger. So that one burger is kind of something that throws a kink in our data. All right? So you can see that the data is spread out more to the right, and that the greatest value is now 2,000, and that 2,000 would be considered an outlier, or an extreme value with few data points near it. So this would be considered an outlier. Even though you might want to say that that is an outlier, when you look at the overall data, it's really not an outlier when you consider you have a 2,000 calorie burger out there, which definitely is an outlier. Alright, so that's kind of a neat way of looking at data. You can look at the way data is spread out by its least greatest value. A neat term is to say, where is the data clustered, if there's any clusters there. So that's how we would look at the spread of data. Why don't you try answering some of these questions? Pause the video and see if you can answer these questions. Alright, let's take a look at what we have. The dot plot shows the duration in minutes of an eruption of the Old Faithful geyser in Yellowstone National Park, and the duration of the eruptions. Okay, so here we have it, and the question asks, where are their groupings of data? Well, in order to answer this, you'd have to take a good look at the data, and you can kind of see where things are kind of grouped there. And the answer would be this. There are groupings of data between 1 and 7/10 minutes and 2 and 3/10 minutes. So right here is a grouping of the data. Most of the data are grouped on the right side of the dot plot, especially between 3 and 7/10 minutes and 4 and 8/10 minutes. So most of the data is going to be grouped right here between the 3 and 7/10 and the 4 and 8/10. Alright, so that's how you would answer this question. Where are the groupings of data in this dot plot? Let's try another question. Number 2. Using the graph of the eruption duration of Old Faithful, where do you think the center of the data is? Explain how you found your answer. So why don't you pause the video and see if you can come up with this answer. Alright, the correct answer in this case, or one consistent with what you're being asked, I think the center of data is about 7 3/10. Okay, so about 7 3/10 would be the center of the data. Okay, right about in there somewhere is the center of the data. I looked at the right side of the middle of the data distribution, and since there are more data points concentrated on that side, my center was closer to that side. So it's kind of neat because even though this is not physically centered with the overall spread, you can see that it is kind of like most of the data is right here, so the center of the data would fall right about there. Okay, and that's why you'd want to pick it at about 3 and 7/10. Alright? See if you can answer this question. Is there an outlier in the data set? Explain. Well, the answer were given by Pearson? No. All data points are near the other points, so there are no outlier in the data. Okay, there's no outliers in this data. So there's nothing extreme to the left, there's nothing extreme to the right. Number 4, see if you can answer this question. Is the shape of the data symmetric or spread to one side? Well, in this case, the answer is that it is spread to the left. Okay? It is spread to the left. All right? So here is the grouping of the data. We remember earlier we talked about that, where most of the data is grouped, but then you can see that it's kind of like pushed this way. Okay? So it is spread to the left. In other words, we knew the center was somewhere right about in here, and the data is spread to the left. One more question. See if you can answer question number 5. What is the least value of the data? What is the greatest value of the data? Alright, in this case you can see that the least value of the data is 1 7/10 minutes, which would be right about here, 1 7/10. And then the greatest value is 5 2/10. Now when you go over a question like this, remember, look at how your number line is set up. Look at how the values are broken down by units. And in this case, they are broken down by every half. So 1 5/10, 2, 2 5/10, 3, 3 5/10, on up to 5. So that's an important thing to remember when you actually identify the greatest and the least values on a plot. Okay? All right, very well. If you have any further questions, you can see your teacher or you can review the materials in your math book.